Hello all, welcome to the Nuclear Technologies panel session, where we will be discussing various small modular reactor technologies. My name is Dazawray Landrie-Parker. I'm a PhD candidate at Johnson Shoyama Graduate School of Public Policy at the University of Saskatchewan and an instructor at Yukon University in the Indigenous Governance degree program. Today, I'm coming to you from Treaty 6 and the homeland of the Métis. First off, I'd like to thank First Nations Power Authority staff and leadership for putting on an amazing and well-organized conference. I've been through many during this COVID time, and this is one of the best organized I've seen. I'd also like to thank this panel's sponsor, Energy NB Power. Today, we're going to have 3 panelists providing us each short presentations, and then we'll have some time for questions and discussion. Please feel free to ask your questions in the question panel as we go. I'll keep an eye on them and ask them at the appropriate time. I'd like to introduce our first panelist, Rory O'Sullivan. Mr. O'Sullivan is the Chief Executive Officer North America at Moltex Energy. He joined the company as Chief Operating Officer in the UK before moving to Canada to set up the North American business. He has a first-class honours in Mechanical and Manufacturing Engineering from Trinity College, Dublin, and a degree in Mechanical Design Engineering from INSA Lyon in France. Welcome, Mr. O'Sullivan.
Thank you very much, Dazawray. And I will also expand on your comments that this event has been probably the best organized, definitely the best organized I've been to. And I have also been to a lot, probably more than one a week since the pandemic hit in March, but they've been useful experiences. So can I get my slides up, please, whenever you're ready? Thank you very much, and we can jump on to the next slide. So we're Moltex Energy. We're developing a small modular reactor here in New Brunswick. I'm speaking from St. John at the moment in our office. And the company was set up only 4 or 5 years ago in the UK with one single objective of finding a nuclear solution that was clean and low cost. We moved to Canada about 3 years ago now because we saw that actually Canada was really the best place to develop this innovative technology. Canada is very committed to climate change and it has a very good environment for innovation and new technology. What we're doing now is primarily design of the reactor and technologies as well as research and development, but we're also doing supply chain development and stakeholder engagement. What we're not going to be doing is the big procurement activities, any manufacturing or any operation. We leave that to others who already know how to do it. We have 4 offices at the moment in Canada, the UK and the US, and we're working with 50 or so organizations all around the world. Next slide, please. So a bit about the technology now. There's really 3 unique aspects to our technology. The first is it costs less, and that's based on the innovation by eliminating hazards, not adding layers of protection. The second is the ability to recycle nuclear waste and reuse that as fuel. And then finally, the third is we're not just promoting nuclear on its own, we're a nuclear and storage solution to enable more renewables. And I'll talk about these 3 briefly now in the next slides. Next slide, please. So this one really just illustrates the first most important point about low cost. The dark blue bars here are the historical capital cost of nuclear power over time. So what you see on the left is in the 70s and up to the early 80s, nuclear power was cheap. It was very low cost. It was cheaper than coal or gas or other fossil sources. But over time, we realized the safety performance of those reactors just wasn't up to scratch. So there was systems added on left, right, top to bottom that just increased the cost. And now you have nuclear power plants, which are the safest plants on Earth, but that comes at a cost. And what happened is you have these facilities that were really designed in the 50s, and then there was features added on to get them to today's safety performance level. Well, we've really gone about nuclear a very different way. We've gone back to basics to see how could you do nuclear differently to get that really impeccable level of safety, but without the complexity which can lead to low cost. And you can see on the right there, the cost estimate done independently of ours that actually get us back to the original cost of nuclear without all the complexity, and we still get the right level of safety. Next slide, please. And the second one is our ability to recycle nuclear waste as fuel. So if we just work from the left, and bear with me here, it's a little technical, but we start off mining uranium, which produces the fuel in for CANDU bundles. That's what happens today. They then go into a CANDU reactor, and we have lots of them around the country, and that produces clean electricity. They currently are stored in reactor sites all around the country. And at the moment, there's a plan to put them in a deep geological repository somewhere in Ontario in the future. That is a sound plan, it's well established, and it's absolutely viable, it's costed. It's the Nuclear Waste Management Organization dealing with that, who you are hearing from just before or after rain. But what we're proposing is a little different. This is what our research is going to evaluate, whether this is possible and feasible economically. We're looking at taking that used fuel that's currently stored at the reactor sites and converting that into fuel for our reactor. We can then produce more clean electricity with our reactor from that waste. Now, we still have some, will still have waste from our reactor, so we can't ever get rid of the problem, but the intention is to really reduce the amount of long-lived waste that needs to go into that storage facility, reduce the complexity and radiotoxicity of it over the long term. Next slide, please. And then the third is our ability to complement renewables. So there's a lot of progress with renewable energy in the last 10, 20 years. However, the planet has spent about $3 trillion in renewables, and actually we haven't changed our carbon emission percentage. We're still at around 36% non-emitting sources. What you need for renewables to be successful is have energy storage. Electric storage is very expensive. We're looking at combining small modular reactors and energy storage so that we can have more renewables on the grid. So what this shows here on the left is our reactor. And then we have big storage tanks that can store the heat produced from the reactor. So you can have a larger capacity for a shorter period. Now, I want to add that we're not talking about the micro reactors for northern communities here. We're talking about big power plants that could run cities. So in New Brunswick, we're looking at a 300 megawatt reactor that could potentially go up to 600 megawatts for shorter periods. So you can really get more value out of the renewables when the sun isn't shining or the wind isn't blowing. Next slide, please. So in terms of First Nations engagement, really we're quite committed to early Indigenous engagement in Canada. Some of the reasons for that are we know this technology is really very disruptive. Nuclear power particularly is quite controversial. So you want to make sure we're really having those discussions as early as possible. But we know the end goal of almost all Canadians is to solve climate change and essentially make the environment in Canada better, and that's with clean energy. So the views are a bit disputed around nuclear. We think it's a clean energy solution. There are some issues with it which we're trying to deal with. So we want to have these early discussions to be able to understand the issues of First Nations as early as possible. And this isn't specifically formal engagement that is required as part of a project. We're way before formal engagement as part of a project. This is really asking the question, do First Nations communities want to actually engage at this early stage? What are the concerns? What does engagement look like? Where we've got to in New Brunswick, our main partnership is with North Shore Mi'kmaq District Council here. And really that was a partnership established around May 2020 this year. And it's to get meaningful, long-lasting relationships, understand what the communities want out of a relationship, partner with the local Indigenous businesses, and most importantly, create high-value jobs for Indigenous youth to work on training programs so they can actually maximize from the benefits of this program in New Brunswick as we move forward. So if there's other communities out there listening, we'd love to hear from you too. We've mainly been engaged in New Brunswick, but of course at some point we'll want to reach out a little bit further across Canada. So if you, next slide, please. My email is here at the bottom of this slide. If you have any questions or want to talk to us, find out what we're doing, please take a screenshot there or a photo and reach out. We'd love to hear from you. Thank you very much for listening.
Perfect. Thank you, Mr. O'Sullivan. So next, I'd like to introduce Norman Sawyer. So Mr. Sawyer is the president and CEO of ARC Nuclear Canada. He has more than 37 years of combined nuclear power industry experience in Canada, and he's been involved in both the operation of commercial nuclear power plants and in the regulation of the Canadian nuclear power industry. Welcome, Mr. Sawyer.
Thank you so much. I first like to start by recognizing that our company, our Canada, is in St. John, New Brunswick, and New Brunswick covers the traditional territories of Wolastoq, Mi'kmaq, and Passamaquoddy peoples, and the region and part of Wabanaki, and we respect that, and we always have, and we've been out discussing with the various First Nations around the province, talking about, as Rory mentioned, what we believe is clean energy. The first slide, please. Okay, next slide. So here we have basically the prototype. So our Canada is bringing to market a prototype on the left. I don't know if you can see that, it's a little bit off skewed, but it's the EBR2. So this little reactor ran for over 30 years. So it's a technology evolution of a proven advanced nuclear type prototype. There's multiple patents involved, and including what we bring to market is a new fuel called metallic fuel, which is much safer and in particular addresses the concern of any releases and things like that. It also addresses technical, economic, and geopolitical barriers because of proliferation-proof type technology that we put together. This technology, if you see on the right-hand side, it's technology to address climate change. And as Rory mentioned, the world is really fighting this right now. And I am one of the believers, and I believe I'm an environmentalist, that nuclear technology can address and assist renewables with the challenge in front of us. So as you can see, the IEA has our technology in their what's called the SMR booklet, which is a bit special because it's about 300 pages long. But also, we were one of the only SMR technologies to be included in the Energy Ministry Nice Future campaign, which is an international campaign which talks about flexible nuclear for clean systems, including renewables. Next slide, please. Over here you see, again, it's a little bit skewed, but on the left-hand side is the little reactor that we put together. And it's really a paradigm shift in reactor manufacturing, much like Rory explained. It operates essentially at no pressure, it's really at all temperature. So, and the coolant is non-toxic, non-corrosive. So what you're building is a technology is extremely safe. So therefore, there's no expensive exotic metals to be used, no massive traditional containment structure. So there's no real permanent requirement to have fueling equipment. So our reactor is fueled once every 20 years. So you load the fuel and the reactor will run for 20 years. So this really lowers the cost, which is essential for the nuclear industry. And the reason for that is that we bring to market an inherent safety features, which really is a natural control of power without human intervention. And it provides exceptional load falling characteristics to combine with renewable. And so it really offers flexibility. And in this little diagram here on the right, you can see the heat storage for peaking ability as was described by Rory. That plays, if you can either use that sort of process, which is an industrial process that's available today, or our reactor can actually follow the grid itself. It also aligns very well because of the temperatures that are produced and hydrogen type production, chemical production, industry in general, and enable an ability to provide clean water through desalination processes. Next slide, please. Again, as mentioned before, it's the use of the waste that's been an issue for the nuclear industry for a number of years. If you can see this clearly, it's we bring flexibility to the market. We have a 20-year fuel cycle, as I mentioned. That's so you fuel once over 20 years, and then you have options. You have option one, which is really with a significant decrease in volume, and use the current approach. But then you have option two, which is really a direct recycle option, where we call it reconstitution, where we can recharge our fuel and use it again for another 20 years. And then option 3, as we talked about earlier, is basically going after some of the used fuel that's already been in place now. And then option 4 is a delayed approach where you can store this what I call reusable energy and use it at a later time. So there's really the flexibility you bring to the market for our reactor going forward here, which is really critical. Next slide, please. As you can see here, when you do this reconstitution, really you have this, with a 20-year fuel cycle, a significant reduction in waste volume and significant waste reduction in safe storage, significant amount of reusable energy. As Rory was explaining, any used fuel that's in play here in Canada now still contains energy that can be used. It's non-proliferation, and it's really a environmental responsible process where it's a dry process. So as you reconstitute your fuel, you don't have the waste issues. So what that means is you're reusing about 93% of the energy again, which only gives you a 7% waste. So this little diagram here is just to compare. This is for about 90,000 homes for 1 year if you're going to use energy, and which is roughly the size of St. John, New Brunswick and Fredericton, New Brunswick combined, just the houses. And you can see the different amount of waste is produced as compared to our technology. Light water reactors, which is mostly in the US, somewhere around 2 metric tons, where the heavy water reactors are somewhere in the vicinity over 16 tons. Our little arc reactor produces less than the other 2 technologies without doing anything. However, if you can reconstitute, you can see it's a couple hundred pounds, which is really addressing one of the major issues, which is waste, but also addresses the cost factor and also the safety factor. So our technology does address all 3 main issues for which we play with today. Thank you very much.
Perfect. Thank you. So our next panelist today, is Claudio. Mr. Claudio is the Director of Sales for NuScale Power, responsible for small modular reactor sales to end users. He leads NuScale's business development presence in Canada and engages federal and provincial governments, supports the needs of interested stakeholders, and engages with non-governmental organizations. Mr. Claudio has a Bachelor's of Engineering in Metallurgy and Material Science from Stevens Institute of Technology in Hoboken, New Jersey. He also participated in the Robert Morris University Executive MBA program in Pittsburgh, Pennsylvania, and the University of Virginia Darden Executive Leadership Program in Charlottesville, Virginia. Welcome, Mr. Claudio.
Thank you, Dazawray. It's great to be here, and I very much appreciate the opportunity from the First Nations Power Authority to speak here today and talk with you about NuScale. How's that sound? Are you able to hear me well? Dazawray, can you hear me okay?
Yes, we can hear you great.
Great. Okay, thank you. So thought we would start with just a small introduction of who NuScale Power is, a little bit about its history and where we find ourselves today. NuScale Power was formed in 2007, the sole purpose of completing the design and commercialization of a small modular reactor, specifically the NuScale Power Module. The concept and the technology behind that small modular reactor was originally developed during testing as a result of a Department of Energy program way back in the year 2000. In 2011, a very notable event happened, and that is that Fluor Corporation, which is a global engineering and construction company, became our lead investor. And what's significant about this on a number of levels is not only did they provide significant level of funding, as an engineering and construction company, they were able to evaluate our design from a constructability point of view. And Fluor Canada also is a member of the Canadian Council of Aboriginal Businesses, and they are a PAR certified member of the CCAB. So we're very pleased to have Fluor as our constructor partner, and it really helps us from taking the design from paper, if you will, to the reality in construction. In 2013, another noteworthy event happened, and that was that NuScale was awarded through a competitive matching fund over $300 million, or since 2013, over $300 million of funding from the Department of Energy in the United States. And this was also a very useful opportunity for us to be able to continue to develop our design, advance it, demonstrate it to the regulator in the United States. And as challenging as a demonstration is, the challenges regarding fundraising are also rather significant. And so this was very helpful from the standpoint of allowing us to get to where we are today. Since the inception of the company, over 530 patents have been granted or are pending in nearly 20 countries. We presently have over 400 employees in offices throughout North America and in the UK. And as recently as this past August, the U.S. Nuclear Regulatory Commission provided a design approval for the NuScale design. To date, NuScale, the total investment in NuScale is approaching $1 billion. Thank you, Dazawray. Next slide, please. So a little bit about what the technology aims to do. We believe it represents a smarter energy source. It's flexible from the standpoint that it can support a number of applications. It can integrate with renewable resources like wind and solar and hydro. It can provide a highly reliable power source when dealing with mission critical facilities like hospitals. And of course, it's a clean base load. It is 100% carbon free. It's as clean as wind and solar, but it stands on a much smaller footprint. And from the standpoint of safety, should it become necessary for the NuScale SMR to shut itself down, it can do so on its own for an indefinite period of time with no operator action, no additional water, no AC or DC power. And it's cost competitive because of the nature that the module is factory built, while at the same time the civil works are going on in the field. We're able to keep the cost down and shorten the schedule because we're doing those two activities in parallel, again, relative to a traditional nuclear power plant. Next slide, Dazawray. So a little bit about the technology itself. At its core, as I mentioned, is the NuScale power module, and that's the picture you see on the left. It stands about 25 meters in height and is about 5 meters in diameter. It's totally factory built. You see the containment vessel on the outside. Inside the containment vessel is a reactor pressure vessel, and the nuclear core is at the bottom. It's a simple design, takes advantage of natural circulation as the mode of transporting heat to the heat exchangers. And once this vessel essentially produces steam, and once the steam comes out of the module and goes to the balance of plant, the rest of the plant is very similar to what you would find in a coal-fired plant. Again, this is factory installed, and each module can produce up to 7,700 megawatts of electricity with its own power conversion system. So incrementally, in our base case with the US NRC, is utilizing up to 12 modules in a building for a total of more than 900 megawatts. However, more recently, as a result of utilizing a power uprate on the module, as a result of focusing more on baseload applications, we're able to extract more energy, thermal energy out of the module. And this has allowed for the development of power systems that have as little as 6 or 4 modules, which is somewhere between 450 and 300 megawatts electric. Next slide, please. So we talked about the module. It goes into the building. In this particular building, this is again our flagship building, which houses 12 modules. Smaller configurations are available. That building sits in the middle of the field, as you see on the bottom right. The total footprint of this particular configuration is about 35 acres or 14 hectares. And it can sit very neatly near population centers as well. And one of the things we'll talk a little bit more about in a moment is coal replacements. So this is the first and only SMR design to receive US NRC design approval. Next slide, please. So one of the things that has been spoken about during this conference, and one of the things that I very much appreciate is the economic impact to the local community and what could be gained from the construction and operation of a NuScale SMR. So here's a little bit as far as numbers that are of materials and components that are required for at least we'll call it the 12-bay building, the larger configuration. So we're talking about 830,000 cubic feet of buildings, 200,000 cubic yards of concrete, and the list goes on. What's notable about this list is that it really doesn't travel very well from the standpoint that you're not going to ship concrete over large distances. So to the extent that a plant of this nature can have a positive impact on the local community, this is the basis of that discussion when we talk about, again, materials, pipe, electrical equipment, and things of that nature. Next slide, please, Dazawray. From a construction standpoint, again, using the model of the 12-bay building, we're looking at about 1,100 jobs just to construct one of the plants. And the list is there. I'm not going to read through them, but very typical of what you would find in major construction projects, and certainly utilizing the local capabilities is something that is of interest to all of us. Next slide, please. From an operation standpoint, we're missing a little something there, but from an operation standpoint, each plant would require about 300 people full time. And as I had mentioned earlier, once the steam is produced and that steam goes into the balance of plant through the power conversion system, and that steam is made into electricity, that process looks very similar to what's already in place in a typical coal-fired plant, where that steam again is turned into electricity. So a number of the jobs that would support a NuScale SMR would also support would be applicable from those that are already being utilized at a coal plant. Next slide, please. And we did a little bit of an analysis as far as what it would take to retain the coal-powered plant workforce. A little bit of a side-by-side comparison. The number of nuclear engineers involved is really not that great. It's more the work that's involved in the balance of plant. And again, this slide presentation is available in the archives. And please, I encourage everyone on the call to take a look at it and look at it in more detail. And again, continue a conversation. Next slide, Dazawray. Again, this is a little truncated, but we speak about the fact that what kind of jobs, these are high quality jobs that will invest locally. On the average, a nuclear power plant generates about $470 million of sales in goods and services in the local community, and pays about $16 million in state and local taxes. Based on the NuScale Idaho reference plant, we discussed the number of construction jobs, and we discussed the number of direct jobs annually to operate the plant. And one more slide, please. And so from a manufacturing standpoint, studies have shown that the need for clean energy globally is very significant. And so to the extent that there's an expectation that there'll be significant demand on NuScale's SMR product, we've done evaluations where we've said, okay, if we were able to produce 3 plants a year, what would that look like from a manufacturing standpoint? And what we've come up with is that from using that as a baseline, we're looking at 13,000 manufacturing jobs to produce the power modules and to be able to support that level of work. Next slide, please. I think that's it. So that's in a nutshell from an economic impact standpoint and a job standpoint. Just wanted to present that and make it available for discussion. Thank you.
Thank you, Mr. Claudio. And thank you to all our panelists for those presentations. Before we move into the questions, I just want to take a moment to mention this panel's gamification code. So for all of those who are collecting points to trade for certain prizes in the marketplace, this is your gamification code for this session. So it's TECH20, TECH 20. So thank you to all of our panelists. We have a couple questions that did come in, and I also have a couple questions. My first one is for Rory. My background is in Indigenous engagement in the nuclear energy sector. So I really enjoyed your presentation and highlighting some of the meaningful and long-lasting engagement that you guys have done in this area. Can you highlight some of the specifics, what has been done and what specifically? We've talked a lot about, needing to have Indigenous engagement and early and often throughout these last couple of days, but what exactly have you done in this area?
Sure, thank you. Yeah, I'd be quite happy to talk through that. So the first engagement we had was in September 2019. Actually, MB Power organized an information session with all of the economic development agencies across First Nation economic development agencies across New Brunswick. And that was really the first sort of touch point, let's say. At the same time, we sponsored a Atlantic Links learning event, which was training for economic development officers and land managers to increase their ability to undertake successful land and economic development opportunities. This was put on by Can Do and Inclusion Works. And then we mainly built the relationship with North Shore and Mi'kmaq District Council, really to get their feedback on what they're interested in, what the benefits are to the communities, what are their concerns. And in February, as I said, we formed this partnership, and really that's for them to get the information about small modular reactors out to their communities was one part of it. The majority of Canadians actually think that nuclear contributes to climate change. So that as a fundamental has got to be resolved, and they were quite passionate about that. I think you'll be speaking to them, hearing from them at some point. Then we're looking at partnering with Indigenous owned businesses, looking at what training opportunities are available to Indigenous youth, because really the big goal is jobs for the longer term. And we don't want this to be a blow in and out construction project there where there's construction jobs and then nothing else. We're building the technology and there's the manufacturing here. So it's not just project jobs, this is long-term jobs. And we've also been out to the other the tribal council chiefs with the Ballistic Way and the Maui, getting their feedback, understanding what their interests are too, and we're hoping to take that forward in the years to come.
Wonderful, thank you. I really like the focus on the long-lasting relationships. I think that is integral to successful consultation and engagement. I have a question for Dom now. So how real is NuScale's SMR? What does that look like?
Well, as I mentioned, it's progressing very well. We've spent almost $1 billion in getting the project to this point. We have a first customer in the United States, the Utah Association of Municipal Power Suppliers. We are working on that project as we speak. We're starting through the licensing process. We've attained our approval from the US NRC. We're more than halfway through the CNSC vendor design review process. And so we believe we have a product with a supply chain being developed, able to support the needs of Canada, United States, North America, globally within this decade. So we're very excited about the process and what we're doing as far as positioning ourselves to support the needs of those who are interested in carbon-free, reliable energy.
Perfect, thank you. So we have a couple questions from our group watching today. The first one is, what is the process for a First Nations construction company or fabricator to qualify as a subcontractor to these OEMs?
So I'll touch on that. So we're, as I mentioned earlier, we're engaged with Fluor. Fluor has a pretty significant presence in Canada. They've been in Canada for over 70 years. They are members of the CCAB. And so I would very much encourage those who are interested to communicate with Fluor Canada and to express their interest. We recently had, with the Organization of Canadian Nuclear Industry, a supplier day, a vendor day, where 200 or so vendors were in attendance and were able to discuss our needs and present a portal to those interested suppliers where they've communicated with us and are working toward becoming on our vendor list. So feel free to contact me, or I can put you in contact directly with Flora as well.
Great, thank you. We have another question around power purchase agreements. So how long would these be, and does OPG have any examples of power purchase agreements for SMRs?
I can take that one. So I don't think any of us can speak for OPG specifically on this. OPG do have a wide range of projects. In New Brunswick, we haven't got to the point of looking at that. Of course, in terms of securing a long-term project, the longer term of the PPA, the better. But that's really up to the utilities. So if you have a chance to ask that question to them later on, perhaps they can. In terms of this, just coming back to the last question on suppliers, I think this might be the same for Norm. We both have supply chain managers here. We've already done local engagement in New Brunswick, and we will be spreading this out to Ontario and across Canada. So if you reach out to me, I gave my email earlier, or if you go to our website, moltexenergy.com, there's a contact us. We'd love to hear from First Nation businesses so we can put you on the register and then reach out at the right time.
Yeah, just to Rory's point and to Donald's point, first of all, PPAs are quite right. Normally it's 20, 25 years. I've been doing them for a long time. Ontario, and as Rory mentioned, as we march closer to construction start, for us is somewhere about mid-2020s. We're getting closer and closer to that day. And obviously, before you start construction, you normally have a PPA in place. So for us, we're just a few years away from it. And secondly, to Rory's point, Rory and I both have held over the last 18 months a number of supply chain events. In fact, we have another one coming up November 24th, and discussing about how to get on. I know Dom used the word vendors list. How to get into the, as you mentioned, the list of people or companies that we would reach out to for various types of information we need to decide how we would move forward with which groups. And certainly you can send an email to clandrie@arcnuclear.com if you want to get invited to the CM&E. It's actually being held by Canadian Manufacturer and Exporters that's hosting us when our upcoming webinar on supply chain. There's all kinds of opportunities. I think all of us, the three of us, would tell you that SMRs I personally believe our SMRs are something coming for the future. The supply chain in particular is very attractive to a province like New Brunswick, where we're going to reinstate and re-energize the supply chain going forward. And it's really interesting to see the dynamics of this. And what surprised me, as I mentioned, I spent a whole career at this, and some other people have too, but to run the big reactors, and you don't really truly understand the impact it has on the economy, on people, everything around you. And this particular call it new supply chain or manufacturing opportunity will really drive growth in many areas across the country. In our analysis, we've looked at something around 50% of what we believe we would need can be done in New Brunswick, but that means there's 50% for the rest of the country to go search. And it doesn't necessarily have to be companies that are in nuclear today. This is an opportunity to get into a business that maybe in the past you have not. And so I would really seriously ask all of you to think about that. And again, for us, clandrie@arcnuclear.com, and we'll make sure you get an invitation to our upcoming supply chain. Thank you.
Thank you. So we have just about 5 minutes left. I have just a couple more questions. I want to just revisit the engagement piece with Indigenous communities. So one of the things I'm always asked when I'm in a community talking about SMRs or talking about nuclear is, what's the benefit? So, how will Indigenous groups benefit from new nuclear? And maybe, Rory, you can give us an example specific to New Brunswick.
Sure. So there's really two main ways people can get, the communities can benefit, aside from climate change and the environmental benefits that everybody benefits from. The first is the jobs. I think we've heard a fair bit about that today. In New Brunswick, that'll mainly be with the companies that are doing the manufacturing of these components and the construction itself. The second one that we've been in discussions with is equity ownership. And this has been quite successful in other big energy projects across Canada. To the best of my knowledge, it hasn't really happened in nuclear, but this is a new opportunity because we're now developing this technology at this early stage. There is potentially opportunity for that, and we're absolutely open to those discussions because although it doesn't happen overnight like developing a new app, the potential size of the opportunity is pretty large. We wish it could happen like an app overnight, but we're still trying.
Definitely. Thank you. I have one more question from the floor, and then we'll probably have to start wrapping it up. And the question is there synergy possibility between these SMRs with battery energy storage technologies? Does anyone want to?
I think the answer to that is yes. In all of our technologies, there's, renewables. One thing that people may not recognize is, like, for example, we did a study for New Brunswick for wind, for example, and we have about 300 megawatts of installed wind in New Brunswick. But however, we only get 100 megawatts from it. So it's only 30% effective. So it's very intermittent. So, you need systems to recharge and to be there, for example, when the wind is no longer there. So you can use backup, and Rory's example of the heat storage is a perfect example, and battery is also. For battery to function, you have to power it up. So you can get energy from anywhere to power it up. But to Rory's point, batteries are extremely expensive right now. And I can't factual, this may not be factual, but I heard somebody say once that if you took all the batteries in the world, you could only run the US economy for about 2 minutes. So there's not that many batteries around. And when you think about it, the waste from a battery, we always talk about nuclear waste, but there's waste from batteries, like there's waste from wind also. There's chemicals in there, there's things like that we're dealing with, that we're going to have to deal with. Solar panels is another one. These are all good technologies, and I think what we're promoting here is that nuclear is part of the solution. It's not all of the solution. It's just one big piece of it. That's all.
The largest battery in the world in operation today is equivalent to our reactor running for about 20 minutes.
20 minutes, there you go.
It's they're useful to have a role, particularly in smaller, more remote areas. They're definitely very valuable, but they are going to be very expensive for a very long time to meet.
Thank you. And I think that's a really good point. Nuclear is part of the solution. It isn't the whole solution. So I think that's a really great key takeaway from today. I'm going to have to wrap it up here. I'm moderating the next panel, so I'm going to have to get running. But I'd like to thank each of our panel members for the presentation and this great discussion. I have a million more questions I would love to ask each of them, but luckily I have their emails now. Luckily for me, maybe not so much for them. But if you'd like further information, each of our panelists today do have an exhibit set up through the virtual trade show, so you can definitely pop over there and connect with them. So the next session is the Indigenous Opportunities from SMR panel, and it will begin in 2 minutes. So I'll meet you all over there. Thank you very much.
Thank you.
Thank you, Dazawray. Good luck.
Thank you.